Hello everyone, welcome to Code Enzyme, and in this video I will be solving it live. So I don't know how many problems I will do, but let's see. So you can hear me what I'm thinking while solving the problems. Okay. Yeah. So 9 seconds left. 9, 7, 6, 5, 4, 3, 2, 1, 0. Yeah. So you are given two integers x and y. We want to repeat the following process until x is 0. If x is greater than y, otherwise set x is equals to x minus y, and y output the final value of y after all the operations. Okay, and we want to do it in big of 1 or big of log n time. So clearly if we have 2 and 5, so if x is greater, then you have to swap, otherwise I have to say x becomes 3 5, then it becomes 2 5. So I think it will be okay. So x is 2, y is 5, then x becomes 3 and y becomes 2. Okay. So you have 2 5, x becomes 3, y becomes 2. Then we have since this is greater, so it becomes 2 3. Then x becomes 1, y becomes 2, then this becomes 1 and this becomes 1 and 0. So in the end we have 1 comma 1. Okay, and let's see when we have 6 3. Okay, so clearly if the GCD is not equals to 1, if the GCD is equals to 1, then we have a 1. If the GCD is not equals to 1, then we have that, and I think the answer is simply the GCD of these two numbers. That's what I think, but I'm always never sure. But let's go with it and see if it works. So let's say CP template, let's say GCD LCM template. Oh, come on, let's take int n and let's take int xy, cn x and y, and cout underscore GCD. I think it was GCD x comma y. Let's see if this works. I think this should pass the test case, but I'm not sure. Let's see if it gives us a correct answer for now. Yeah, let's move on to the next problem. So we have count subarrays for given a permutation of length p, given a permutation p of length n for I in range n. We want to find the number of subarrays p with some I. Okay, note that the permutation of length n consists of all integers from 1 to n exactly once. Okay, so we have to find the number of subarrays of p with some I. Okay, I think this might be interesting, but let's see. Let's first write the input format. So we have an integer n, and then we need to take the input. So for I, cn, I mean p of I. Okay. Okay. So we have this. Now what can we do to get this permutation? Yeah. So I think we should also have one more number here. For each test case, output on the n space where ith integer denotes the number of subarrays with some I. I don't understand. Like for 2, okay, so 1 comma 2, the only possible subarray is 1, and so first we have to find out the number of subarrays with some 1, then some 2, then some 3, like that. Okay, So 1 then 1 2 like that. Okay. Let's try to see. Let's say we have some permutation. First let's check the time complexity that I need to solve this problem. So n goes to 2 into 10 to the power 5. So I have to solve for every I in log n time, the number in log n time. Like obviously if my answer is 1, for 2 I will always have 2 as my number. For 3 I can take 1 comma 2 and make 3. So only if 1 and 2 are together I will get it, otherwise I will never get the for 3 equals to like that. Yeah. Seriously, like for 4 I can either choose 1 comma 3 and I can't choose 2 comma 2 or something like that. But for 5 I can also get 1 comma 4, or I can get 2 plus 3 equals to 5. Yeah. Yes, let's say for 6 I can take 1 comma 6, 2 comma 4, 3 comma not 3 comma 3. So for even integers I have one less. For 7 I can go for 1 comma 6, 2 comma 4, 2 comma 5, 3 comma 4. So you have 3 possibilities. So I will have maximum, at max the answer can go till n by 2, I think, right? At max n minus 1 by 2. Yeah. So at max the answer can, for every I, the answer can maximum be n by 2 minus 1. Now I need to check that if some case is possible or not for every number. Like okay, let's say I have some, I think I will do it for some better test case. So let's try forming some test case. So import a random. Okay, now from this random let's just take this as input. Okay, and a is equals to I for I in range 1 to n plus 1 and random dot shuffle n. Okay, not n, a, and then I need to print a. Let's say I am only considering 4 numbers till now, and let's try to solve it by hand for this array. So if we have, or let's try some bigger number, let's say for 6. Okay, so if we have some arrays like 2 1 5 4 3 and 6. So for 1 we will only have 1, obviously. For 2 we will only have 1. For 3 since 1 and 2 are together I can take so the answer will be 2. For 4 I can take I should 1 is there. Okay, now who is the neighbor of 1? Like wait a second, can I make 3? I mean there can be subarrays such that n separate subarrays such that they note the number of subarrays with some I. Okay, let's write a brute force code for this. Like my answer will be equals to I in range n plus 1. Okay, I mean the sum of the entire array will obviously be less than this. So now let's write for I in range n, for j in range I plus 1 till n, sub is equals to a of I to j. Okay, let's print sub. So we are going from 5 5 2 5 3 5 6 5 4. Let's go till j plus 1. Not j plus 1. Okay, because this is starting from 0. Okay, I think this is correct, more correct. Yeah. Okay, let's say let's take the sum of this subarray. If sub is less than equals to n, not sum, if sub is less than equals to n, then I can say answer of sub plus equals to 1, and then I can simply print a and print answer. Okay, answer of from 1 to end. So we have this. Okay, now let's try taking the sum. Let's say for 5 I will increase. Okay, let's say I have this array 5 1 4 3 2 and 6. Okay, initially all are, let's say 1. Let's say all we have zeros, 0 1 2 3 4 and 5. For 5 I will increase my answer by 1, then this increases my count by 1, so I can say 6. Okay, I had 6 numbers. Okay, then I will increase my answer by 1, then 6 plus 4 is 10, which is greater than 6, so I will remove this 5. So 1 plus 4 is also 5, so I will increase my count by 2 to 2. Then 4 plus 3 is 7, so I will remove it. 4 plus 3, then I will remove it again. Okay, then 3 is so I get a count of 3. Okay, 3, and then 3 plus 2 is 5, so this becomes 3. So when I remove something, I also need to do that plus plus, I think. Yeah. When you remove it, so what I can do is first I can create a window. Let's say vector int window. Okay, so and let's say also say int window sum. Okay, and I will also have an answer variable. Okay, which are whose everything currently is 0. Okay, now so let's say window sum is initially 0, and for I in range n. Okay, if my first I'm going to do if sum plus equals to what should I say, let's say window sum, let's make a because I'm let's make a DQ instead of vector. Okay, window dot push back what p of I. Okay, and sum plus equals to p of I, not sum, window sum. Okay, now if there is this, if window sum is greater than n, so if it is greater than n, then I'm going to remove not if, I should do it while. So while window sum is greater than n, I'm going to remove one element from the front. So let's say int x is equals to window sum dot pop left, not window sum, window pop front. Okay, and window dot front, then sum minus equals to x, and answer of x plus plus obviously, and after this I'm going to say window sum, not window sum, answer of window sum plus plus for int I in answer, cout I with a space, or I can say for I1 till cout answer I with a space, and let's try this test case. First test case, 5 integers, 5 1 4 6. Okay. No, this is actually very wrong. think there should be if window sum greater than n, then I'm going to do this while loop. Else I'm going to do this. So now we have 10014. Okay. Now why am I getting this? This is very wrong. I think this is because I wrote here a 5. It should be 6. Okay. Now I have 11131, and the answer of this should be A is equals to what? 5, 1, 4, 3, 2, and 6. So 1111, which is wrong again. 3, and there should be a 2. Okay. Now can I get a 2 again? Like 5, 1, 4, 3, 2, and 6. Okay, 5 plus 1 was 6. So why am I not getting it? Because in the end, I can say after this, while window dot empty, while window is not empty, I can say answer of window dot front plus plus and window dot pop front. So this is correct. Let's run this, and it is failing. So for 1 I am getting a wrong answer. Like, okay, for 1 we have window sum equals 1. Window sum is not greater than 1, and I am doing that. Okay, window sum is greater than 1, else if window dot size is greater than 2, greater than 1, then only do that, otherwise don't do it. So it passes the test case. Let's try to submit this and see if it is working. Okay, we got a wrong answer, and let's try to form some new test cases and see if it is working. Okay, so for this test case, the answer is this. So 254163. 254163. What is the answer that I am getting? I am getting 11121. So 111, which is correct. Okay, let's try one more. 6125. We have 612543. The answer is 112111. So I think what I'm going to do is let's just print star A and star answer. This is like completely opposite to what I was expecting, but nothing can be done, I guess. So this is okay. 643. We are getting a wrong answer here because no, we are getting a correct answer. Okay, that was my bad. I think I'm going to try and increase my my n, so such that I will get a better answer. Let's try. I think 7 will work. Okay, let's try this. For 7, these numbers, the answer is this. Okay, so So we got a wrong answer, 1 1 1 2 1 1 and 3. So for this process I was failing. So we have 1 3 4 7 2 5 and 6, and the answer should be like, how do I calculate? So currently my, let's say 0 1 2 3 4 5 6 and 7. I'm going to calculate my answer. Currently I have all zeros, let's say. Okay, and now okay, let's say my starting, if I am on 7, then I can't go above it. Okay, I mean okay, let's say we have 7. I can't go over 7, obviously. Now if I am at 1, let's first increase my count by 1. Can I increase, can I go right? Yes, I can go right. So I will go right. 1 plus 3 is 4, so I will increase my count by 1. Then I can't take 4, so I will cut it. Now I'm starting with 3. I can't go 3 plus 4 is 7. So yeah, let's increase the count by 1. Now I can't take 7, so okay, let's say I'm on 4, so increase my count to 2. Then let's go right again. Okay, 7 plus 4, so I can't go right. Okay, I can't go right. I am on 2. 2 plus 5 is 7, so let's say 2. 5 plus 6 was 11, I can't go. Okay, I'm on 5. Let's say 1. 5 plus 6 11. 1 1 1 1 2 1 1. What? The expected output for 7 is 3. I mean 3 plus 4 is 7. 5 plus, okay, 3 4 5 6. I have 6. This should be 2. I think there is something wrong with my code. Am I printing all the subarrays that are possible? Let's say for n equals to 2. So we are getting 2, 2, 1 and 2. Which is correct. Let's say for n equals to 3. 3, 3, 2, 3, 2, 1, 2, 2, 1 and 1, which is correct, yeah. So I am getting all of them, doesn't matter. If sum of all other than the sum, okay. So 1, 1, 1, 2, 3, 1. And here also we are getting a wrong answer. Let's say 9 1 3 2 8 4 6 7 5 and 10. I mean there won't be too many operations here, I think. So what I can do is for every number I will keep taking the sum. Like, okay, since if it is my end number like 10, then obviously I can't take the sum. So okay, let's say let's do it like this. Let's do a brute force manner for I in range n. Okay, for j in range, let's say I to n and sum equals to I. Okay, let's say and sum equals to 0. Okay, s plus equals to p of j, and if s less than equals to n, then answer of s plus plus, else break. And then for I in range 1 to n, see out answer I with a space. Okay, I think but I think this will give me a TLE. Let's just try this out. Oh, we got a correct answer for this one. I think my rating is going down today. Let's go for the third question here. Suppose you have an array B consisting of m non-negative integers. B is called good if you can make all the elements of B equal to 0 by performing the following operation any possibly 0 number of times. Select any two indices I and j. Let x equals to bi or bj, where or denotes the bitwise or. Replace bi with x minus bi and bj with x minus bj. Okay. And now you are given integers n and k. Count the number of arrays a of length n such that, and a is good. Okay, I think we have some time in our hand, so we can do it actually. Suppose you have an array B consisting of m non-negative integer. M is called good if you can make all the elements of B equals to 0. Okay, so M is an array and okay. Select two indices I and j such that bi is equals to bj, and I think it is optimal to take the equal elements. What do we have to print it here? Count the number of arrays a of length n. Okay, so we want to count the number of arrays such that this is possible. Okay, I think this is a very hard question, but let's see. Why can't I see my rating here? Generally I used to get a graph here. Okay, only 35 people have solved it, but okay. Let's see. So we have what do we have as the input? Let's see. So first thing is n and k. Okay, int n and k, cn n and k. Okay, now we want to solve this. A is good. Okay, the first line contains the first line of each test case contains two integers n and k, the length of a and the parameter k. Okay, now k is equals to 0. What does it mean? K is the parameter k. Select two indices I, j. Where is k here? 2 to the power k. Okay. I get it now. Okay, so we can AI can go from 0 to 2 to the power k. So all the numbers from 0 to 2 to the power k, and we want to print the answer in modulo this number. So let me update this mod value, otherwise I will be getting wrong answers for unnecessarily. Okay, so we have this. Now how do we go about it? Like since it is 0, then if k is 0, then obviously I can't get any number. I will if k is 0, let's say if k is equals to 0, then obviously my answer will be 1, because all the elements will always be no, not like that. Okay, I think there is this case. Can I get 0 as my answer? Can I get 0 as my answer? Let's try some examples. Like let's say k equals to 1. So if my k is equals to 1, let's set k equals to 1. So my array ai can only be 0 or 1, right? So 0 till 2 to the power 0. Okay, let's say k equals to 0. We have for k equals to 0. For k equals to 0, we have only two possibilities, 0 or 1. So in my array there can only be 0 0 or 1 1. What do we have here? B is called 0 if you can make all the elements of B equals to 0 by performing the following operation, possibly 0. So I need to think about a case when I can't make it 0, such that if I have 0 and 1. Okay, suppose I have some 2 to the power k number, and I think I need to have at least two numbers with it. I can have 2, 4, so nc2 plus nc4 plus nc6 and so on. Okay, and since this is 2 to the power k, if we are talking about 2 to the power k, then from n I can choose any two indices and make their that equals to 0, or I can choose any four indices or make their to the power k with equal to, or I can set their to the power k with, yeah, I can do that. Or what I can do is okay, let's see, 3 में से I can either say nothing, so 1 is possible. Okay, so if we have three numbers, I can say 1 1 and 0 and the permutations of it, so 3C2 permutations, yeah. Or what I can do is I can say, okay, let all of them be 0, so that is equals to one possibility that all of them are 0. Okay, now 3C2 is how much? Like 3C2, I can't take 3C4, 3C4. I think this is pretty simple. What I can do is first I can calculate the factorials, because n is going till 10 to the power 6. So we have to calculate this answer in big O of 1. Now since all the numbers are even, so NC2 plus NC4 like that. I think can I reduce this? So if we have NC2 plus NC4 plus NC6 and so on. I know NC0 is 1, so that is one case. Like 2C0 is 1, 2C2 is 1. Can I make all of them equals to, I can't set, right? One possibility is the 2 to the power k is a special bit. If I am setting that to 1, then okay, if some integer is 0, then I can make it 2 to the power k, I think. Okay, I think I can solve this, but this will be hard. Let's see, we have 2 to the power 0 equals to 1 and we want to select two integers, so I can obviously, if either both are 0, okay, and or I can say both are 1. So why isn't the answer equals to 1? The only array satisfying the condition is, why not 1 1? Because 2 to the power 0 is this less than? Okay, it is less than, so there is only one possibility, 0 0, yeah. Then we have 2 to the power 2, so 2 to the power 2 is 4, so I can either select 0 1 and 2. Okay, so what I was worrying about is something I do not have to consider. Now 0 1 2, so I can say, okay, let's not set any bit 0, and since I can select any two, so here I can say, okay, let's take both of them 0. I think I should not consider this, like if I'm taking both of them 0, I don't have to consider this. Okay, let's not consider 0 part, at least for now. If I'm setting 1, like the first bit is equals to 1, then I have to say 2C2, set both of two numbers equals to 1, or I can set 2C plus the possibility of setting two numbers, not two, actually four numbers, like 2C4, which is 0, so I do not have to consider it anymore. So 2C2 is 1, yeah, and 2C2 is equals to 1, so I think the answer is, okay, two C0 is 1, 2C0 that don't select 2 is 1. One case. For the kth bit, I am thinking like 2C0 is 1, 2C2 is 1, 2C, and set both of them is also 1. So we have two possibility, and for 1 we have two possibility. So yeah, I think I get it right now. 2C0 plus 2C2, which is equals to, yeah, I think I get it. Okay, let's say this is just a long shot, but let's see. So first I'm going to make two arrays, integer factorial of since my maximum n can go till 1 2 3 4 5 6, right? 10 to the power 6. 1 2 3 4 5 6. Yeah, let's go one more step just to avoid anything crazy. Factorial, and let's also have inverse factorial. Okay, and I'm going to use my mod inverse template. Okay, so what can we do now? If we have my mod inverse template, I can just first of all I have to calculate all the modulus. So let's say factorial of 0 equals to 1 for now, and inverse factorial of 0 is equals to mod inverse. Why is this not working? I think this is because even I am not sure now. Wait a second, do we have some square root L? Okay, should parity of x and y be equal? Huffman coding, no. Okay, mod inverse 1. Okay, then for I in range 1 to like factorial of 1 till capital N. Okay, and I can say factorial of I is equals to factorial of I minus 1 times I, right? Okay, then inverse factorial of I is equals to mod inverse factorial I. So now I've calculated the factorial values, then I can now calculate NCR values. So int NCR, right? So int NCR of int A comma int B, int N comma int R, this will return obviously if R equals 0, then return 1, else return factorial N upon factorial N minus R times actually not inverse factorial N minus R, and let's take modulus also. After that I need to multiply this by inverse factorial R. So that is how we are calculating NCR, and then take mod again. Okay, so n minus r n factorial upon r factorial into n minus r factorial, right? So we have this NCR formula. Now like for every k I can let's say obviously my answer will be at least 1. Now for I in range every k from 1 to k, I can say answer star equals to, or I can say answer is equals to answer times, like I need to get a summation value, right? How do I get a summation? So some number, so for that I can say let's say int x equals to 0 for now. 2c0 was 1, 2c1 was 2, so I need to go in steps of k. So for j in range from 0 to that number n, and less than, actually j less than equals to n and j plus equals to 2. Okay, x plus equals to NCR n comma j, right? And answer is equals to answer times x mod let's see if it works. And now it failed miserably. Yeah, so we have for this value I'm going from 1 to k, like 2 to the power 2. 2 to the power 2 was 4. Let's go for equal to, just in case. Okay, now for 343, We have 2 to the power 343, which is a very big number. Yeah. I think this will require some more understanding of maths. Let's see. First of all, how many people have actually completed this? Okay, more than 100. So this problem is doable actually. Yeah. Okay, so for every number, I have to see how many numbers can I make. Like, can I do one higher or one lower? Is the recording on? Yeah. Can I make a number? Can I make a number for the kth bit? Okay, let's see. For a kth bit, I can either set it or unset it for some numbers. So if I have 2 to the power 343, I can set 2 to the power 342 value to some numbers. And obviously, if that is even, so that will be equals to NC. First, I am not setting that bit. Then I am setting, okay, let's choose any 2 and set it. Otherwise, I am setting, let's choose any 3 and set it. NC4 and set it. Okay. Okay. And also, if r is greater than n, return 0. Yeah. For j is equals to 0 till j till n, j plus equals to 2. C out x. Let's also try my debug template. I think this value is actually constant. That's what I think. Like this value that I'm calculating is kind of constant. So I should just calculate it here and keep it with me. Right. Like 343C0. Why is this happening? So this is working, and I think I forgot to take modulus. Okay, so we have this. So x is this value, and in the answer we have this value. Okay, so our solution passed. Let's try to submit this and see if it is working. Okay, we are getting a time limit exceeded. Why is this? Because we are multiplying something. So we are raising this to a power, right? So x is, we are, our answer is simply answer. So I can use binary exponentiation, right? So answer is equals to simply bin power x, I think. So instead of this loop, I can say bin power x to the power, what should I say, k. Yeah. And we are still getting our time limit exceeded. Why? I think because of this. This is running in big O of n. Now, how can I reduce this? Like if I have nc0 plus nc2 plus nc4 and so on, and can I reduce this? Is there a thing like nc0 plus nc2 plus nc4 nc6 and so on? Let's Google this up. Can I get a value? So we have nc0 plus nc1 okay, 2 to the power n, which is 2 to the power n minus 1. Okay, so we have 2 to the power n minus 1. So I can simply replace this by x is equals to bin paw what 2 to the power n minus 1, and this question will be of simply binary exponentiation. Okay, so let's try to submit this and see if it gives us a correct answer. Okay, we got a correct answer. Let's move on to the next problem. Okay, my rank is I think it will update in a minute. Let's see the next problem. Okay, so we have find permutation. You are given an array A of length 2n consisting exactly 2 occurrences of each integer from 1 to n. Find a permutation P of length n such that for each 1 to n, if we delete occurrences of Pj for all I j till n from A without changing the order of the remaining elements, there will be at most mod A by 2 elements between the occurrences of Pi in the remaining A. It is guaranteed that one of such permutation always exists. If multiple such permutations exist, we may print any of them. Note that a permutation of length n consists of all integers from 1 to n exactly once. Okay, so basically we are given a permutation of length n, and if we delete both occurrences of pj, okay, we are given an array of length 2n consisting of exactly 2 occurrences of each integer. Okay. So if we delete both occurrences of pj for all from A without changing the order of the remaining integer, there will be at most A by 2 elements between both occurrences of pi in the remaining array. What was that? Let's see the sample input first and try to understand the test case. So we have cpp cp template. First we have this single integer t, then case of positive number n, and then we have an array of 2n. Okay. Okay, so we have this now.
I didn't catch that. Could you try again?
Okay, so we have this now. Let's try. Hmm. AI occurs exactly twice in A. The sum of n over all test case won't exceed 3 into 10 to the power 5. Let's see what my rank is currently. It is 412. I don't know why this is not updating, and why am I having the old interface of Codechef right now. But let's see. I want to check my rank in my college. Hmm. What? Why is it showing I've only solved 2 problems? But I solved 3. I don't know why this is happening to me, but I think it will get fixed with time. Yeah, let's see. We have this input format. Okay, for each output we output for each test case output a single line of n separated integers denoting a valid permutation p. It is guaranteed that one such permutation always exists. So we have 1 1. Okay, 1 to do 1. Consider the permutation 2 comma 1. For I equal to 1, we delete p2 equals to 1, and array is obtained 1 1. There are 0 elements between the both occurrence of p1 equals to 2. I don't understand this. Wait, why is my rank not increasing? I'm more concerned about that. And why is it showing my score is only 200? But it should have been more, right? I think the information will update in 118 seconds, so let's wait for that. This is really concerning now. Okay, so we are given an array A of 2n length and consisting of exactly 2 occurrences of each integer I. Okay, it is guaranteed that one such permutation always exists. If multiple permutation exist, you may print any of them. Note that a permutation of length n consists of all integers from 1 to n exactly once. If we delete both occurrences of pj for all I to n, okay, from a without changing the order, the remaining element, there should be at most the length of a by 2 elements between both occurrences of pi. I still don't understand this. We have a permutation of length n, and for each 1 less than equals to I to n, if we delete both occurrences of pj, so j is some number which is from 1 more than I to n, okay. If we delete both occurrences of pj for all, okay, there should be at most mod a by 2 elements, ज़्यादा से ज़्यादा mod a by 2 then a by 2 elements between, okay, remaining in a, okay. So let's see, if I have this array 1 1 2 2 3 3, okay, so I want to find in that is if we delete both occurrences of p2, p2 equals to 1 and p3 equals to 2 and obtain the array I don't know why I can't understand it, But let's make the tutorial video for now. Okay, my rank got updated now. Hey, wait a second, why this is more than 100 submission? I can do this, I know. Yep. So we have 1,1. We have 1, 2, 2 and 1. 1, 1, 2, 2, 3, 3. 1, 1, 2, 2 and 3, 3. Now how do I go about this? Like if we have we delete both occurrences of p2 equals to 1 from A to obtain 2, 2 where there are 0 elements between the both occurrences of p1 equals to 2. Each test case consists of 2 lines. The first line of each test case contains a positive integer n of length of the length of the array is 2n. The second line contains 2n separated integers. We delete both occurrences of p2 equals to 1. So p2 equals to 1. What does p2 equals to 1 mean? Pj find a permutation of length n such that for each, if I have I equals to 1, then I want to if we delete both occurrences of pj from 2 to n from A without changing the order of the remaining elements, there should be at most mod A by 2 between both occurrences of pi in the remaining A. So why not? It will always be there. If multiple such permutation exist, you may print any of them. Why can't we take 1, 2? If I delete both the elements, if I delete everything, there will still be. If I take 1, 2, 3, if I delete 1, 1, I'm not sure. Like if we delete both occurrences of pj without changing the order of the remaining elements, there will be at most ज़्यादा से ज़्यादा, इससे ज़्यादा नहीं, mod a by 2 लेंथ से ज़्यादा नहीं होनी चाहिए, mod a by 2 elements between both occurrences of pi in the remaining array. Okay, I think let's find a counter for this case. Let's say we have 1 and 1 here. No, let's say we have 3 and 3 somewhere, and 2, 2, 1, 1. So if we have something like, let's say if we have something like 3, 3, 2, 2, 1, 1. Okay, if you have something like this, then my permutation, if the first element is 3 and I'm deleting no, the first element can't be 3, right? Such that p of for each I pi, if we delete both occurrences of pi pj, I still don't understand this. The test cases are shit. I just can't understand the problem, and that is why I won't be able to solve it. Mm, 150 people have solved this problem. 1 1 2 2 3 3. Okay, 1 2 2 1. It is clearly telling me that if I have 2 1. Okay, so first, what is this? For I equal to 1, we delete both occurrence of p2, both occurrences of 1. Yeah. Okay, and after where there are 0 elements between the occurrences of p1. Yeah. For I equal to 2, the array is 1 to 2 1, where there are 2 elements between both occurrences of 1. Okay, okay, I think I get it now. Yeah. So we have 1 2 2 1. If we choose 1 comma 2, then we have to delete these two and we get a 1 1, which is correct. But if we for 2, I can still print 1 comma 2 there also. I think this is a problem of stack. I don't need to think much about it. Like, okay, we have first I need to check how many elements are there between the two elements. Like, okay, can I make pairs? Like, for this one I can choose anything. It won't matter because there are no elements in between. Let's try to make some random test cases. Okay, so what I'm going to do is I'm going to say for I in range n, a is equals to a plus a. Then let's print a, and not 10, let's try for 3 only. So 3 2 3. If we have this test case, so 3 2 3 1 2 and 1, what should be my answer here? So if I have to select any I have to print a permutation of p such that, like, okay, let's try for something for all the p's. Like, since I have a 3 comma 3 and 2, so 3 should come first, 2 should come later. Okay, and since I have 1 2 1, so can 1 come first? So 1, if I delete all 3's and 2's, so this will work. Then 3, if I delete only 2's, then this works. Okay, I think this is working, but let's see if we have 3 1 2 2 1 3. Okay, what 3 1 2 2 3? Okay, like that. Now if my first element is 3 and I delete everything, it works. Like, okay, my largest element can always be in always come first. So observation 1, like, what I can say from here is that, let's try to write my observations. Largest element can always come first. Okay, let's talk about the second largest element. Like, if I have the largest element, all numbers will be deleted and we will have at least 2 elements in them. But what about the second element? Can I pick 1 here? If I pick 1 here and then 2 and 3 are all deleted, smallest element can also come first. Like, why not? What about the second one? Can I pick 2? Like, if I have 2 and I'm deleting 1 and 3, any element can come first basically. That is not how we go about this problem. Let's try some different thing, like 4 5 3 2 1. Say 4 5 4 5. and if I have something like 4 and 5 are coming before then 3, then uh, if I have something like this, if I have something like this, then what will happen is these will get discarded. Then we have 3, 4, 5, 4, 5, and 3, 1, 2, 3, 4, 5, 6, which is incorrect. So 3 has to come before 4, 5. Yeah. I think I get it. I think I get it now. Like if I have both occurrences of some number, okay, and it is surrounded by one more number. Let's try to form a DQ as my answer. Let's say DQ int answer, okay. Or I should do it with the help of a stack, I think, but I think this will work. Now I want to make two pointers. Like let's try to find out the how should I say this? Like if I have two numbers and 4, then this works. Okay, it works. It kind of really works. Like now, I think I can do this using what should I say? The topological sort. Can I do it using topological sort? Like I know 4 and 4 come here, 5 and 5 come here, and 3 and 3 surrounds it. So obviously, before 4 or 5, my 3 should come. So how can I say this? Like 4 and 5, 5 and 5, or 4, 5, 4, 5 also works. But if it is completely disjoint, like in this range from 3, something else is coming, 4, 5 which is completely disjoint, then that will disrupt my answer. It can also happen like 4, 4, 5, 3, 3, and 5 here. Then after 4, 5 we get a 3, all the elements are removed, then this also doesn't work. But I think this works. 3, 4, 5, 3, 4, 5. Then we are good. I think if in the occurrence, if I think if the distance between these is greater than 2, okay, then whatever the elements are, okay, I think I get it. I think I get it now. I think we can do it using topological sort. Okay. So let's say vector int graph of n plus 1, right? After that, I mean, what is the time complexity that we have? So 3 into 10 to the power 5. I think we can solve it using topological sort. So first thing I'm going to do is first I'm going to see, like, are there any occurrences? Like for I equals to 1. No, that won't work. I don't think that will work. Because n and searching for this is okay, 10% battery. Let me just put this on charge, because the time complexity is going way higher if I use topological sort. Okay, so I can't use topological sort here. What can I use? If I can't go with topological sort, then maybe let's say 1 1, let's say 3 4 5 and 6 and 3. Okay, so 3 should come before all these elements, right? So I'll push it into the array. Okay, I mean, it won't. Maybe it will pass. Maybe it will fail. What is the time complexity that we need? Okay, let's try to code a brute force solution, and then I will try another um, a better approach maybe if it doesn't work. So pair intent, and let's say positions, and positions of all the n plus 1. Okay, now so we have this, and what I can say is if initially let it be everything is 0 0, so if position of a of I dot first equals 0, okay, then I can say position of a of I equals I. Let's say minus 1 comma minus 1, as I can't take 0, so equals of minus 1, else positions of a of I dot second equals y. Okay, so now I got all the positions of the something like that. I got all the positions that I can get. Now I need to find, can I visualize this like, okay, let's try my interval visualizer. Okay, we have this. Let's say my 3 is going from position 1 2 3 4 5, 1 2 5, okay, 4 is going from 2 to 4, 3 is going from I think I can simply say whichever is coming first, let's give that number a chance, and yeah, maybe like that. Let's make a set instead of this position. What I can say is or maybe answer if s dot uh, find a of I equals to s dot end, so it was not in the set, then I can simply say answer dot pushback a of I and s dot insert a of I. Yeah, and at the end C out, or maybe for int x in answer C out x with a space, and then C out handle. Maybe that will work, maybe that won't, I'm not sure. Okay, so I'm getting something completely different. Okay, so first I have a 1, so it was not okay, so I got a 1, then I got a 1, then 2, why didn't this work? Okay, so because I only went for a single loop, not twice. So I'm getting a 1 2 3 also works, 1 and 2. Why am I getting a 1 and 2? Because I have 1 2 2, so 1 should come before 2, but since it was like that, I mean, let's try this. I mean, maybe it will pass, maybe it will fail, but it doesn't hurt to try, I think. Oh, I got a correct answer. That was a pure luck. I don't know how I did it, but yeah. I mean, I was not expecting to get a correct answer on this question, but okay. Construct permutation. I'm not sure if I will be able to solve this, but okay, let's see. You're given an integer n and k, and okay, let's see my rank for now. Hmm. Vishwavidyalaya. Oh, why is it not showing that I've completed this problem? Whatever, it will. I think it will be get updated soon. Let's see this problem. Okay, so you are given integers n and k, and you want to find a permutation p of length n such that for I equals to 1 to n, and we have this. Okay, I'm not sure if I will be able to solve this, so let me first try to make the editorial videos for these problems. And maybe I will. Yeah, I think I'm not sure if I will be able to solve this problem. Let's see the division 1 for now. Okay, and even in division 1 we only have okay, we have 73. I think I can solve this. Let's see. B, construct permutation. You are given a permutation p of length n such that I to okay, max of pi minus min of p pj equals to k. If there exists a multiple, we can print any one, otherwise report that it is not possible. Okay, so we have not Java. What happened? Okay, so we have this. Now you are given a permutation p of length n such that summation of pj, okay, max summation of pj minus min summation of pj for all in range in the prefix. Okay, so in every prefix the max minus min should be equals to k. I think is it ever possible, because the first element should be equals to 0. Yeah, for 0 I think it is possible, because for the first case, if we have 0, okay, we have n and k, so int n and k, c in n and k. Okay, so as the first element will obviously be 0 for if there exists a multiple p, because max pj minus min pj will be 0 for the first element, so I think k should always be 0 in this case. So we had 0. Then for the third test case we had a 0. Okay, should this be constant for all? If there exists a multiple p, they can print any one, otherwise report that answer is not possible. The summation, okay, I forgot, this is not equal to it, it is a summation of this. Okay, so obviously in the first it will be, at first it will be equals to 0 for I equals to 1. Then I mean, what can I say about this? Let's try to find something by brute force. Where is my Codechef.py? Okay, so we have this. Now what I can do is I can randomly shuffle it, and my k goes to 0, and now I can do for all for I in range n, for j in range I. Okay, what can I do? I need to take the maximum and minimum. So I mean I can do x is equals to max a of I plus 1 till a of I plus 1, y is equals to min from a of from starting from a this to this, and k plus equals to x minus y, and then I have to print k. Let's say two integers, and if my 1 2, if it is 1 2, if it is an array of 1, then k must be 0. Okay, if it is an array of 2, then the possibility of k is whether it is 1 2 or 2 1, k can only be 1. Okay, let's see what happens when k is equals to 3. If we have 1 2 3, my answer is 3. Okay, can I get something different? We can also get 4. When you have 1 3 2, the maximum is 3, obviously. Okay, I think this is a dynamic programming problem. I don't know why, but it seems like a dynamic programming problem, because how can I go about this? Okay, my rank is right not 400, which is bad. 200. Okay, let's see. We want to solve this using, maybe I think we want to solve this using dp, and in big of n time also. K is still n square. Okay, let's try something like what do we get when we have a is equals to, when we don't shuffle it. So for 1 2 3 we are getting a 3, for 1 2 3 4 we are getting a 6. So basically when we have 1 2 3 and 4, so minimum will remain constant, maximum might change, right? For whenever I have, let's say dp of I is equals to the answer for this, so dp of n will store my answer, obviously. Now since if I'm at a current, why am I wasting my time on this? Like because I have to make a permutation such that occurs, and if that is the case, for k equals to 6, I think there is no other permutation which will give me this answer. If k equals to 6, how does my k vary? Let's see, print k. From k 0 1 3 6, it is getting 3 is getting added at each step. Let's say k equals to 5, then 1 3 6 10, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Yeah. Okay, let's try to randomly shuffle this also. For 1 we had 0, then we got a new maximum. Okay, minimum is constant. Let's again try to shuffle this. I think I will print my a before. Okay, let's say we had 4, then for for this range 4 was maximum. Okay, let's say we have 4 1 3 5 and 2. Okay, so we have a 4, and can we add something like, I think I will make editorial. I will spend 8 minutes on this problem, and if I can come up with something I will do it, otherwise I will make the editorial videos. Yeah. So 41352, we have 41352. How do we go about this? Like if I'm on 4, then I can say 4 1. Like obviously this will give me a 0. When I get a 1, my maximum doesn't change but my minimum changes. So I will have to increase my answer by, like currently my factor was equals to 0. Now my factor is equals to uh, no, I want to go in reverse order. If I have a k, I want to form a permutation of length. Then can I print all permutations of, let's see, what do we have to do if we want to generate all possible permutations? Is there a function? Yeah. Okay, we have permutation. Then we can list all the permutations in this range. And let's go to this permutation range 1 to n. I think n plus 1 and k. Let's see. Let's also take k as input. If s is equals k, print p. So let's try this. Like if I want only one, I will not have anything. Can I get a 2? No. Can I get a 3? No. Can I get a 4? No. Can I get a 5? No. Can I get a 10? Yeah. So there are several permit. Okay, let's go for 6. Okay, no. Can I get a 7? Again, no. Can I get a 8? No. Can I get a 9? No. Can I get a 10? Okay, I can. So the starting value is 10. Okay. There are so many permutations which can give me 10. We have 5, 4, 3, 2, 1. Can I get an 11? Let's see. Let's try some easier test case like 4. No. Let's try for 3 only. Can I get a 0? No. Can I get a 1? No. Can I get a 2? No. Can I get a 3? Again. Okay, so for at least n, I need to have, I can get 1, 2, 3, 2, 1, 3 and 3, 3, 1. Can I get a 4? Can I get a 5? Again, no. Okay. I don't think I can solve this today. There are only 31 minutes remaining and very few people have solved it. So, okay. I think I will go for a dinner now. So thanks guys if you have watched it here. I will see you guys next time. Thank you.